then I can go ahead and introduce you if that is fine. And I must also say that once you've clicked on accept, you have accepted that we'll be recording this. And today we have I call him one of Africa's finest, and he's also a board member of the African Materials Research Society. The person who will be giving us the talk today is no other person than Professor Malik Maaza. He's current incumbent in South Africa, and he's a UNESCO chair in nanosciences. And he has a joint appointment with the University of South Africa and the National Research Foundation of South Africa. And the National Research Foundation, Itemba Labs. He is a fellow of the various academics, including the African Academy of Sciences, the European Academy of Art and Sciences, as well as the National Society of Chemistry, London. Prof. Malik Mazza has been bestowed several honors and accolades, among which is the African Union Kwame Nkrumah Award for Excellence in Science and Technology and the Galileo Galilei Award for the International Commission for Optics. He has an H index of 97 with a total citations above 28,000. He's one of the leading scientists in this field. And today he will be talking to us about nanomaterials and R&D and the translation, a pathway towards the sustainable development goals, where we're looking at science for society. So Prof, we thank you so much that you took time off your busy schedule to be here with us. We are very, very grateful, and we hope to enjoy your talk. And Prof, over to you. Can I also suggest that Prof will do the talk after that? When he's doing the talk, please, you can put your questions in the chat, or after he finished the talk, we'll have an opportunity to ask questions where we can actually go depth into whatever Prof is presenting. So Prof Maaza, over to you. Thank you so much, and we are glad to have you.
Thank you, Program Director, dear senior and junior colleagues. First of all, allow me to express my deepest gratitude to the organizers for their kind invitation in associating us in this endeavor of the AMRS. And I wish also to express my gratitude to each and all of the participants here present for taking of their precious time and coming to attend this talk, which is a part of the African Material Research Society vision and mission and activities within the years. My talk of today, colleagues, if you allow me just to share with you the perspective of the nanomaterials or materials at the nanoscale and their potential impact on the society, and in particular in resolving the challenges which are proper not only to Africa and the global South, but to humanity as a whole. And what I will be sharing with you, colleagues, it is a product somehow of a long-term cooperation with a number of colleagues within the region of Africa and beyond, and specifically involving extensively our members of the diaspora, to whom we are deeply and extraordinarily recognized for their inputs and for allowing us and giving us the potential, both the moral and the financial support, as well as the infrastructure to reach where we are. We are not at the top level, certainly, but I think we are at the level where we are confident to be able to resolve some of our urgent problems locally. So this talk, dear Chair and colleagues, junior and seniors, is given within the framework of the Nanoscience African Network, as well as the UNESCO UNISA Africa Chair in Nanosciences and Nanotechnology. The UNESCO Africa Nanochair is a trilateral partnership between the UNESCO plus Fontenoy in Paris and the University of South Africa, which is one of, if not the oldest university in effect in South Africa, by contrary to what is very well established that UCT is the old institution. No, give back to Caesar which belongs to Caesar. History is history. UNISA gave a birth to, in effect, to UCT. And UNISA has, how can I say, celebrated this year, last year, 150 years old in terms of existence. And the University of South Africa has 9 campuses all over the African province, South African 9 provinces, and it's the sole institution, high education institution, which has a satellite or a campus out of South Africa, that is in Addis Ababa via a memorandum of an understanding, an agreement in effect with the African Union in Addis Ababa in Ethiopia. And also, of course, UNISA is an institution which has 2 Nobel laureates as alumni, and UNISA has 2 major platforms in the field of nanosciences and nanotechnology, Nanoswater and the UNESCO Africa Nanochair. Of course, the major second player of this trilateral partnership between the UNESCO, UNISA is Itamba Labs and the National Research Foundation of South Africa. Itamba Labs is the largest national facility of the National Research Foundation of South Africa, and it has 2 major nodes, one in Gauteng and the other one here in the Western Cape, where we are based. Itamba Labs is a major player of radioisotope production worldwide. For example, if you use a PET scan in Melbourne or in Tokyo or in Washington or in Tallahassee in Florida or in Moscow or in Uppsala in Sweden or in Buenos Aires in Argentina, rest assured that sodium that you are using for the diagnostic comes from, in effect, from Itamba Labs as the sole supplier of such a radioisotope, because it is extremely cost effective and cost competitive relatively to what India or China can produce. So it shows that when excellence it is also possible to have such excellence in Africa, not because I am associated to Itamba Labs, certainly not, colleagues. It's just to crystal clear indicate that Africa also do possess not only corruption, HIV, tuberculosis, poverty, hunger, and so on, but there are some pockets of excellence in science, and as we see also in soccer. And that gives us a hope somehow for Africa. And just, colleagues, to set the scene more or less, what is the landscape of nano in Africa, is that as early as the 90s, when the National Nanotechnology Initiative in the US has been implemented, Europe and Japan and other countries also implemented, and so are the number of African countries who embarked in the field of nanosciences and nanotechnology, starting by the South African Nanotechnology Initiative, then the Amanat in Morocco, then the Egyptian Nanotechnology Society, then the Tunisia, then Nigeria and Kenya, as well as Zimbabwe. But it's not, colleagues, limited to that. While all these national initiatives are targeting national agenda, the Nanoscience African Network, which was created in 2005 in Trieste, to whom and in Italy, to whom we are extremely grateful, and there are no words in the Arabs or in the Larousse to express our gratitude to the ICTP and the Trieste system of science and technology and education. After 2005, the UNESCO has made a call in 2012 to create a chair, a UNESCO chair in the field of nanosciences and nanotechnology. And in that time, considering the track records of the Nano AFNet now, which is led by and the chairman now is Professor Balan Gom, the current president of the African Materials Research Society. He is also the chair of the Nanoscience African Network. After the Nano AFNet and its track records, the UNESCO chair has bestowed Africa with this UNESCO chair, which has been launched in 2013. and sorry, colleagues, and since 2013, the UNESCO chair is operating. That is said, colleagues, what is sure is that while we have the number of national initiatives were targeting somehow, as well as the UNESCO chair and the NanoAfnet were targeting the creation of the critical mass within the African continent, both nationally, regionally, and continentally, there is a need to embark in an entrepreneurship and to have a mind shift within the youth coming both in Africa and the global south, that is Iran, India, Middle East, China, Bangladesh, and so on, to come with the, how can I say, R&D translations and to benefit from it, not only science, fundamental science and knowledge production, but also to use this nano field or multidisciplinary field of nanosciences and nanotechnology to come and respond to the challenge, the societal challenges of the global south, of course, without, of course, in partnership with our colleagues from the north. Whatever we do is a part of humanity as a whole. It is not, how can I say, resolving water contamination or trapping CO2 and convert it into a valuable product. It's not only proper to Africa or the South, but it is the humanity as a whole. And it happened that nanotech is a potential market and a driving force for the economy. For example, it is expected that the compound annual growth rate of nano between 2023 and 28 is around plus 10%. That means that, how can I say, that means that it is possible to invest and to have 10% increase in whatever you invest as a ROI, somehow, return on investment. So Africa should tap on this possibility. And in that regard, colleagues, it happened that within the South, the field of nanosciences and nanotechnology, while in the past, the South nations have neglected the science and technology, I think with the field of nanosciences and nanotechnology, policymakers have understood there is something to be done there, and therefore to take the case of South Korea and China and Malaysia as a typical examples, and to embark in the field of nanosciences and nanotechnology. And colleagues, here, for example, is the nanotechnology publications per GDP. Okay, per GDP, that's the number of articles relatively to the billions invested in science, billions in science relatively within the full economy and the financial system of a country. It happened that, colleagues, you can see that the number of African countries are there in the field of nanosciences and nanotechnology. Yes, they are not at the top of the league, but they are there. That means there is definitely a wake-up message from the policymakers to invest in the field of nanosciences and nanotechnology, and specifically the material science, and to see that it's worth of investing in it. And well, you can clearly see that Tunisia is the top of the league, South Africa and Egypt, but other countries in Africa are also part of it. And relatively to what is worldwide the average, it seems that we are doing not bad somehow. And you can see that Iran, a global player in the South, is coming in force and doing better than South Korea and Singapore. And colleagues, that trend is more or less following within the years. It's sustainable. Doesn't matter, colleagues. The point is the policymakers are now convinced to invest in the field of nanosciences and nanotechnology in Africa. The chair, please, colleagues, and the NanoAfnet are official platforms of the of the nanosciences within the continent, because the NanoAFNet is a node of a network of excellence recognized by the African Union, and the chair, of course, is recognized by a UN agency that is the UNESCO. Colleagues, while the NanoAFNet was focused only on Africa, the UNESCO chair is focused on Africa and beyond Africa. That includes the global south and our colleagues from the north, to whom we are extremely grateful, because members of the diaspora and because our colleagues from the north, generally speaking, have contributed so much to us, elevating us to reach such a level. And colleagues, the UNESCO chair has two major nodes, one in Johannesburg in the Gauteng, where our program director is located, and the other node is in the Cape. And you are more than welcome to visit us in whatever nodes you wish. And colleagues, the chair, when we initiated Nano within the African continent, we have targeted 6 pillars. Pillar 1, create a workforce, a multi-skilled workforce, and therefore embark in a nano program of postgrad at MSc and PhD level since 2005 up to now and beyond. The second one is to do the same thing, but for create a human capital mobility within the African continent, specifically geared towards emerging young scientists and senior scientists. Target number 3 is to create a nano master at the continental level. Program 4 is to create a nano journal, which would be recognized soon by, and would be the voice, will be recognized by Scopus and indexed on all standard databases, and to to voice the excellence of the nano within the continent. And of course, it's not a journal for Africans, but for the world. And we said that in 2023 we should embark in entrepreneurship, R&D translations, as well as patenting. So as you can understand, the colleagues, program 1 we were successful, program 2 were successful, 50% because we created a joint nano master programs with a number of countries, but not at the continental level, because we have still the francophone and the anglophone systems, and the lusophone system, and the Spanish system. And we have program 4, we have been successful. We created Nano Horizons, which is an initiative between UNISA Publishing House, the Royal Society in the UK, and Open Science International in Germany. And since 2005, we have non-stop supported and trained a number of fellows in the field of human capital development. And for example, Dr. Simon Shigome from Bitri was a student through this NanoAFNet. The Professor Balangom was a student through this system, and you can see the quality of the fellows. They are outstanding, high caliber young scientists, fast growing, and you can see clearly that this program have managed. What I will do, colleagues, with you, if you allow me to do so, I will embark in program 5 and 6 and share with you what we have achieved so far in terms of R&D translations and potential IP and patenting and so on. But I will give you some examples of 1, 2, 3, and 4, and go to share with you some typical examples of R&D translations, colleagues. Here, colleagues, some of the fellows who have been trained within this program, as you can see, from different parts of the continent, including word zones. So in that time, it was this country were unstable, Rwanda and Libya, but we brought these fellows down here to ensure that they are ready when the peace process starts in their countries respectively, and they go and serve their nation as it should be. And we were not limited, of course, to Africa. We have extended it, of course, to the south. Here is Dr. Kaviarusu, one of the brilliant, fast-growing scientists. We have fellows from Yemen, for example. This fellow from Yemen, still the instability of Yemen, and of course you have the colleague from Ethiopia, Tigray region, and the Sudan, and so on and so on. So just to single some, and of course gender aspect is extremely critical. We have a rule of taking 50% of our fellows males, 50% are females, to ensure that there is gender equity in that regard, because Africa is losing 50% of its GDP, because 50% of the workforce of the continent is not considered, and it's under it. And the United Nations. Above, colleagues, as you would see, above the excellence and so on, the quality education that we give to our fellows is reflected by their profiles. Professor Ngob and Professor Shigome and others are just outstanding scientists who have now created their own groups and managing a high-level organization, including the AMRS and others. But as you can see, colleagues, here are the citations by the international community of our publication produced within the framework of the NanoAFNet and the UNESCO chair. And as you can see, colleagues, this African dynamic, both mobility of junior and seniors, have allowed us, and involving members of the diaspora in particular, colleagues. The diaspora is an extreme major component that we have neglected in the past, that we should not neglect anymore. They are the ones, they are the engine. They are truly the engine, and we have really to ensure that we leach ourselves with them. And as you can see, colleagues, the citations went from some tens to hundreds to thousands. And these, colleagues, are citations by colleagues from China, from the US, from Russia, from Australia, New Zealand, Europe, and Latin America and Central America. It reflects that what we do produce is somehow of quality, not excellence, but quality. We are not at the top. We are not looking for the top, but we are producing with our limited resources quality in terms of nano research, colleagues. And we should continue. We should not, hopefully it will not plateau here. We are not looking for an exponential, otherwise we will die, but we are looking for a steady increase somehow. So, colleagues, within the framework of the UNESCO chair, within the framework of the University of South Africa, which has contributed for 150 years towards knowledge production and preparing the workforce of today and tomorrow and the past, now we have to address the problem of the society. And it's a must. We have a moral obligation to do so, because what we are, any rand, any dollar that we are using, any CFA that franc CFA or euro that we are using, it's the taxpayer money. It's coming from our colleagues, our members of the street, and partners from the north and the south. We should really give, how can I say, give back to Caesar which belongs to Caesar, and to Cleopatra which belongs to Cleopatra. In that regard, colleagues, I will share you some of the translations, and you would understand the translation that we are targeting? Are all of them in a way or another targeting one of the Sustainable Development Goals? If you are not aware about them, I plead to you, I beg you, please take just some of your time and go and read what are these SDGs, because if each of us would contribute a nanometer, just a nanometer length to them, or nanosecond time of to them, we will be able to protect our Earth, this Mother Earth, this rock that we call Earth, that we have tarnished, we have affected negatively somehow. It's never late. We have to put some efforts in addressing, in a way or another, one of the SDGs. If we do so, we will definitely be able to save it and to create a better world for the future generations. Thank you. Colleagues, the first one that I would like is to single out sustainable SDG 3, which is related to health and well-being. And I would like to share with you a typical success story in terms of R&D translations. For this case in particular, colleagues, what happened is that 4 major fellows have been involved: a PhD student from South Africa, a postdoc in the chemistry sciences from South Africa, an emerging young scientist from Egypt, and an emerging young scientist from Iran, a computational person, a physicist, a life science, a chemist, and a life science and computational, somehow a management also person. What we have done, colleagues, these fellows went, and as you can see, we involved colleagues from the South, Iran, Pakistan, Belgium, and so on, and India. And colleagues, we try to address a problem. Southern Africa receives high irradiation, high DNI, high direct normal incidence from the sun, which means that you have a huge amount of UV radiation, and therefore, if you do not protect your skin, UV definitely will affect your DNA and will create the cancer skin melanoma. Colleagues, do you still hear me?
Yes, we can hear you, sir. Go ahead.
Thank you, because I have had a problem with the stability of the connection. Anyway, thank you. What is sure is that there is a huge problem of skin cancer melanoma. And the colleagues have done their homework, and they have identified there is a community that we call Khoisan, a black community that we call Khoisan, based at the frontier between Namibia, Botswana, and South Africa. And these people, in effect, they have a low skin melanoma cancer. And we have found out that they use a plant that we call Hoodia gordoni to, how can I say, put on their skin as a protection. And what we have done, colleagues, we took that Hoodia gordoni, as you can see here, and that Hoodia gordoni, in effect, it has what we call phytocompounds, which is called P57, yes, phytocompound P57, and this P57 is an anti-thirst and anti-hunger. So it is used by this phytocompound is very active to remove fat. But other phytocompounds in this Hoodia gordoni, if you powder it, you will take it and you use use a natural extract of it to make nanoscaled cerium oxide. You will find out that this nanocerium oxide, as you can see, colleagues, it's highly crystalline. It's extremely highly crystalline, and it's better. It's as of a high quality as if you use a physical method or a chemical method to synthesize highly crystalline particles of cerium oxide. And you can see, colleagues, that its UV is a very effective. It stops the UVA, UVB, and UVC relatively to the ones that we find in the market, where they are effective just in one or two fields. But this one is a very long one: UVA, UVB, and UVC. And colleagues, as you can see here, this is the diffuse reflectance of this nano bioengineered ceria. As you can see, colleagues, the UV is at the really limit of detection. It's really at the limit of detection. In addition, colleagues, which means that it stops the UV effectively, as you can see, UVA, UVB, UVC. And better than that, colleagues, the ROS activity of this nanoceria, which was bioengineered using this plant, Hoodia gordoni, which was borrowed from an indigenous knowledge, colleagues, it has a very low ROS relatively to the standard TiO2 and ZNO. What does it mean, colleagues? And when you put this cream on your skin, it stops the UV indeed, but it does not affect the DNA, while the standard ones at a high concentration, they do affect the DNA. While this one, it is not the case, colleagues. As you can see, which means that this new formulation could be as an effective protection cream, colloidal cream for skin protection in cosmetics. And you would understand, colleagues, that this is just a translation of an indigenous knowledge. What we have done, we borrowed the knowledge from our Black community of the Khoisan. We have identified somehow, instead to take the P57, we have identified somehow the correct phytocompound which chelates the cerium nitrate, which allows us to produce cerium oxide, highly crystalline cerium oxide at room temperature and at atmospheric pressure without zero energy input. There is no annealing and nothing. And better than that, using only water as a universal solvent, but not using any harsh oxidoreduction chemicals. So really, colleagues, here it is one of the R&D translations. The second one, which is also related, colleagues, to an indigenous knowledge, it happened that the Himba community also have the lowest, if not nearly zero cancer melanoma, and they have zero bacterial infections. Yet these colleagues, this community, this Black community that is called Himba people, they do live in the south of Angola and the north of Namibia. These colleagues, indeed, these family members of the African community, do not shower. They do not use water to shower, colleagues. And they have no bacterial stuff, none. And colleagues, what they do, they take a red ochre from the mines. They know what type of red ochre they have to take. And they take that red ochre and they ground it in a form of a powder, and they mix it with a goat milk to make a formulation, a cream. And colleagues, when you investigated that this red ochre, you will find that it is nanoscaled platelets. It's a lamellar type, and it's nanoscaled. And colleagues, better than that, when you do the diffuse reflectance, when you investigate the optical properties of this red ochre, which is in effect, you'll find it's an iron oxide, which is an iron oxide, colleague. It stops not 100% the UV, but it stops the UV effectively. Better than that, colleagues, it stops it reflects back 50% of the infrared radiation from the sun. What does it mean, colleagues? It protects from the UV radiation from skin cancer, melanoma, one, and also it stops, it reflects back the heat, the infrared from the sun, at least 50%, which means that it protects their skin from overburn. Better than that, colleagues, we now know why they do not have with bacterial infections, because even their genital part, they don't wash, colleagues. They don't wash. They shower in another form, either genitals and so on, and personal regions. They do not have, because when they take that colloidal suspension, colleagues, they put it from all over their body, including their genital parts. And colleagues, you would see that the antibacterial response of that red ochre that they use is as if it's effective as an antibacterial relatively to the very dangerous, hazardous E. coli and Staphylococcus aureus. As you can see, the response, it's quite high. Colleagues, do you hear me?
Yes, Prof, we can hear you.
Thank you. As I mentioned, I have a really instability of internet. Anyway, colleagues, as you can see, the efficiency is not as good as the streptomycin, which is the standard pharmaceutical. This streptomycin costs $100. This one does not cost us such $100. The Himba people go and take the rock from the mine that they know exactly where, and they use the goat milk to make formulation. So we know, colleague, why they don't have bacterial infection. Nonetheless, colleagues, these are an R&D translation from purely indigenous knowledge, and the scientific proof that indigenous knowledge is valid indeed. And of course, colleagues, you would understand that also it came to how can I say, quality publication by youngsters, by students. I would like to go to something else, colleagues, which is related to the possibility of addressing the food shortage or food price. Colleagues, the food price, all of us, we are suffering from it because the fertilizers are, the major suppliers of fertilizers are Russia, Belarus, and Ukraine. You are aware that this war and instability in that region would impact indeed the prices of the fertilizers. And in that regard, colleagues, Africa included. So we requested from 2 agri students under the chair, and a physicist and a material scientist and a chemist to come with a potential solution, as you can see, from South Africa, from Egypt, Botswana, and the DRC Congo. And as you can see, colleagues, I will not go through the details here, but here is the consumption of the fertilizers within the years from 60 to 2014. As you can see, the bulk is Asia, the second is North America, the third is Europe, and after South America. And Africa is really a very small, very tiny stripe. Why? Because the cost of the fertilizers, even in the past, and you would guess what would be the prices in the future. So we have to come and produce or demonstrate or validate the possibility of producing our local fertilizers at a certain extent. In this regard, colleagues, these fellows that I have mentioned, let me please rendre à César ce qui est à César, Cleopatra, to Cleopatra, which belongs to Cleopatra. These are the fellows who came with this success story. This is the biosynthesis and the bioengineering. And these 2 ones from the DRC and Botswana demonstrated that it's an effective, how can I say? Here is what we do, colleagues. We convert the CO2 through a process to nanoscaled calcium carbonate. As you can see, colleagues, here is a nanoscaled carbonate. It's like a tubular, highly porous calcium carbonate, which is so nano that it can diffuse easily within the roots of a plant or the leaves of a plant if you spray. And what we have done, our homework shows us that Russia controls the nitrogen fertilizers, while Morocco around 24 phosphates, 24%, and other countries. But mainly potash is Ukraine. And here it is possible to get a slice of that market, at least for our local needs. And in that regard, colleagues, here is a typical example of a tomato plant. Without, how can I say, here tomato plant without any nano fertilizer, with a small concentration, with an average concentration, with a high concentration, but still always below the concentration threshold. And you can see, as Saint Thomas, we believe what we see. Comme Saint on voit, on croit que ce qu'on voit. Here, colleagues, without any fertilizer, with a low concentration, with a medium concentration, with a high concentration, colleagues, the nutrient value, as you can see, the size speaks for itself, and the nutrient value is the same, colleagues. And that means that it is the nano calcium carbonate that is produced is a really effective as a nano fertilizer. And colleagues, that how can I say, this publication has been, there was it was patented indeed, and also, colleagues, it was published open access to ensure that all the community would be able to do it, in particular the rural area farmers, whom we will be training, how can I say, show them how to prepare and so on, and show them the right process to follow so they can produce their nanofertilizers themselves locally, and how can I say, so to minimize the cost and to increase the harvest in a green way again. Colleagues, what we are the way that we are doing it is using natural extract, in this case of a plant which comes from Egypt, but other plants have been identified, and the phytocompound active in it will be identified soon. But nonetheless, it is open source. You can get it, produce it, please. And just you are not allowed to make kilograms of it because there is a patent, but for your own garden you may do, definitely. The other burden, colleagues, which is related to SDG 6, colleagues, the first one was SDG 3, the second one was SDG 2, yes, hunger, and the SDG 6, colleagues, is clean water and sanitation. It's really a major problem, in a sense that also in this case, colleagues, you have a PhD student from Senegal, South African postdoc, an emerging young scientist from Egypt, emerging young postdoc from Iran, and an engineer from Iran also. As you colleagues, combining their conjugating their talents and their expertise and so on, they managed to come with something which would clean water at room temperature through an IR, how can I say, if you proceed exactly with the way that we have described in the paper and in the patent, you would be able to indeed produce this material. Why it's extremely important, colleagues, to embark in photocatalyst, which have to be cost effective and can be produced in a green way, not a harsh way, a green way, a bioengineering approach. For such, colleagues, in particular in Africa, you would see these are the provisions or the prospective study of the United Nations and the Water Council, the World Water Council, and here is the how can I say, the reflecting the water scarcity in 1990. This in the cyan bars, this is the water level in 1990, and the dark bars will be the level of water by 2025, that is next year. As you can see, colleagues, the bulk of the African countries will be under vulnerability, and some of them will be under scarcity. South Africa is a part of it, Egypt is a part of it, Somalia, Malawi, Rwanda, Burundi, Kenya, and so on. So it is necessary, colleagues. It is of an urgency, colleagues, that water, which is used in the agri sector containing pesticides, and the water in particular, this one, which is a massive, a huge amount, should be cleaned, colleagues, should be treated to be reused again, colleagues. And for such, colleagues, that is the one that we have targeted, the water used in the agri sector, which is contaminated with the pesticides. So for such, colleagues, we have had to design what we call black titania. Titania is white in general. We are all aware about the bruchite, the anatase, and the rutile phases. But there is also a defective. All of them are white or a little bit yellowish, depending on the defects. But there is a black titania. That black titania, you get it when there is a huge oxygen defects on the surface of the titania. And that, if you have that, you would create a level within the, how can I say, the band gap, and that level that you create makes this black titania absorbing extensively in the UV-Vis, and therefore photoactive in that range, and even more or less at the near infrared. And colleagues, we embarked in the titania here. The patent is still on, colleagues, but soon there will be a publication, and we will share with you exactly the methodology of producing it and so on. And here, colleagues, here is a sample with the methylene blue. As you can see, the peak of the absorbance of the methylene blue. And if you mix with the titania, black titania, for 30 minutes, you can see the discoloration. After 120 minutes, colleagues, it becomes nearly transparent. That means the methylene blue has been decomposed, not 100%. As you can see, still you have something close to zero, but nonetheless, you have killed the methylene blue at least at more than 90%. Not 100%, but more than 90%. And therefore, it shows that you can treat the pesticide contaminated water, because if you decontaminate, if you decompose the methylene blue, you would be able to decompose any pesticide. This is more or less, the methylene blue is the reference somehow. And colleagues, this is more or less the time framework of the decomposition of the methylene blue with the time with this black titania. As you can see, it's not sacrificial because of process, because you have your black titania at the bottom. The other example that I would like to share with you, colleagues, is what we call nanofluids. It's really important that you embark, if you have an opportunity, colleagues, to embark in nanofluids, please do so, because it's a really hot subject. And in this regard also, colleagues, we combine physicists in terms of know-how, a student from South Africa, a physicist from Morocco, a chemist from South Africa, and postdoc from Iran, computational, and my son from Iran, from the engineering side point of view, combining and conjugating the knowledge of these bright minds and coming to what we call synthesizing what we call nanofluids. Nanofluid is a fluid which has a possibility to remove heat or to transfer heat far better than the normal coolants. So it's a new generation of coolants. I would just simply said, colleagues, here more or less, this is the diagram of the energy produced by different means, being it fuel cells, being it solar energy, being it name it. That energy, in effect, goes and produce energy, different processes. 50% of it is used, but 50% of it is lost as a heat. So this heat, wasted energy, should be reconfigured and used as as an effective energy. So we are losing, instead to come with the new technologies, hydrogen, name it, and so on. At least the energies that we are having are effective, but we are losing 50%. Colleagues, instead of creating a new process or a new what, just get that heat that we are losing. Let's have that heat and convert it to a green heat instead of waste. And here, what we do, colleagues, let's go to an idea of James Clerk Maxwell, the equation of Maxwell, les équations de Maxwell. All of us, we heard them. All of us, we have used the nabla. We calculated the electric field, the magnetic field, what, the dielectric constant, what. So just let's take the concept, that beautiful mind conceptualized by James Clerk Maxwell, and let us use what we call a nanofluid. Nanofluid, colleagues, it's a pity that I have not showed it here. I lost, I think, a slide. A nanofluid, colleagues, is a fluid within which you put nanoparticles. The heat conductivity of water, colleagues, the heat conductivity of water, I'm sorry, I really lost one or two slides. The thermal conductivity of any coolant that we use in any heat engine or heat generating engine is less than 1 watt per meter per Kelvin. Colleagues, I repeat myself, any coolant that we are using in whatever, name it, in any engine is less than 1 watt per Kelvin per meter. While copper, silver, and their oxides, they have a thermal conductivity 1 order or 2 order of magnitude higher. So the idea of Maxwell is, let's use let's use particles of metals or their oxides. Let's put them in a normal fluid coolant, and the thermal conductivity should be higher, which is right, because thermal conductivity is a thermodynamic additive component. Therefore, the thermal conductivity of a nanofluid will be higher. If the particles are large, they will settle down. But if they are due to the gravitation, but if they are nano, they will not settle down, colleagues, because the Brownian motion will take over. And therefore, you will have always a nano suspension of nanoparticles, which have a heat thermal conductivity suspended in a standard coolant, water, ethylene glycol, oil, name it. So you understand, colleagues, that the thermal conductivity of a nanofluid will be higher than the normal fluid. For example, if you take an engine, colleagues, if you take an engine, or before coming to the engine, let me go to the thermal conductivity. Here, colleagues, is the thermal conductivity of ethylene glycol. Okay, it's somewhere here. Now, if you take ethylene glycol containing graphene carpets decorated with the silver nanoparticles, the thermal conductivity moves from 0.32 to 0.40. What does it mean, colleagues? Here you will say, oh, moving from 32% to 40% is not high. No, 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 no. Don't fool yourself. This increase is huge. It's 33%. It's a huge in terms of enhancement of thermal conductivity. It's a huge. What does it mean, colleagues? That means if you take an engine and you use the pure water, at each cycle, colleagues, the cold water goes to the engine and removes a small amount of heat because its thermal conductivity is less than 1 watt per meter. And therefore, it will remove small amount of heat. It goes back to the radiator. It's cooled with a fan and the air coming in and so on. And it's cooled down a little bit. The second cycle, it comes and it will remove small amount of heat from the engine and so on and so on. But if you use a nanofluid, colleague, you would understand at each cycle, you remove a huge amount of heat, which would, how can I say, colleagues, put less heat pressure on the engine. And by putting less heat pressure on the engine, it will enhance its lifetime. And if it does that, which means at each cycle, you will use less kerosene, less fuel, so you will pay less, you will emit less CO2 and the NOx. So it is necessary to use these nanofluids. And one of the large scale, how can I say, currently ongoing scale of the usage of nanofluids is to cool data centers, and by Google in Finland and Norway. And I think, colleagues, for the sake of time, of course, you can use the nanofluids to cool down photovoltaics. As you can see, as you are aware, colleagues, the efficiency of a photovoltaic diminishes by 1% if the temperature increases by 5%, by 5 degrees Celsius. So you are obliged to cool down. If you cool down with water, how can I say, not much, but if you use a nanofluid to cool down a photovoltaic, you will be not in the red regime, but you will be always in the blue regime, always keeping the high efficiency of the conversion of the photovoltaic, and therefore high effectiveness of the operation of the photovoltaic, and the longer lifetime, colleagues, less damage created. But what is sure, colleagues, this is one of the potential applications that are, and in fact, I'm glad that one of my previous fellows, who is now a colleague, Dr. Salah Hamlish, is involved in this, and also in colleagues from Morocco and Europe. Colleagues, I don't think that I will have enough time. I will go straight forward, colleagues, for the last one, not this one, but for this one, the last one, colleagues, this one. Colleagues, here is a way to catch the CO2 and convert it to calcium carbonate. Remember, there are different ways, colleagues, to minimize the CO2 footprint. And in this case, colleagues, these four colleagues, Dr. Hamza from Egypt, Nandipa from postdoc from South Africa, Shor Azizi, emerging young scientist from Iran, and Karen from South Africa, life scientist. With them, we managed to come with a green process, converting the CO2 to, or using the CO2 to make calcium carbonates and any carbonate. Think about any carbonate. These fellows have done it. Yeah, they went like a hell, a Chinese or Japanese way. The Mendeleev table. Allez, paf, one by one. That's what they have done, colleagues. And let me just share with you, colleagues, these are a part of climate change actions. And here, colleagues, please, the importance that one should absolutely understand what these fellows were doing. They are gaining from both sides. In 2028, you will be receiving money if you are contributing in removing CO2. Now, what if you are that is 2028, huh? This is 2028. You will start having money if you can claim and receive money if you are removing, if you can show that you are removing CO2, and if you are removing CO2. These youngsters here, what they are doing, they are removing CO2, but that by 2028 they will be able to claim money for such. But colleagues, better than that, not only they are claiming money, or they will be claiming money in 2028, but they are contributing to clean our planet. So they are contributing to more or less ensure that the humanity will be safe in the future and the next generations. But colleagues, not only that, we are taking this CO2 and converting it to carbonates. And these carbonate, colleagues, allow me to tell you why we were obliged and we felt that it is our moral obligation to showcase from the African perspective, but South African perspective specifically. As you can see, colleagues, in terms of emission by, how can I say, by population, and you can see Africa is extremely low, but not South Africa. South Africa is close to China. This is per capita, colleagues. That South Africa is as a robust emitter as China. If you bring that to the population, what does it mean, colleagues? That means South Africa is polluting. Yes, South Africa is the polluter number one, or emitter of CO2 number one in Africa, and the 13 worldwide. 13 worldwide, colleagues. And here, colleagues, more or less, these are the culprit, the big emitter of CO2 in the continent. That is South Africa, Egypt, Algeria, Libya, Morocco, Nigeria, and Angola, and somehow Ethiopia and Kenya. But the one is South Africa. So we are obliged, we thought that we are obliged, morally speaking, to contribute and to come with a potential solution that we share with the whole community, not in Africa only, but how can I say, in the global South and the global North. This matter is a part of humanity. We cannot keep a knowledge with us, but we have to share it with. You may think that we are dreamers and the big business. Okay, fine, no problem. As much as we clean, leave whoever wants to make business, whoever wants to make bucks and so on. Leave them. The point is, our earth is in danger, and it's time to act on it indeed. And we have the workforce for such. For the decarbonization, colleagues, there are different ways. Either you take the CO2, you sequestrate it underwater, in the mines, in the moths, name it, in porous media, what. And there is the CO2 cycling, and there is the CO2 conversion. The conversion, there are three major ones: physical techniques, chemical techniques, and CO2 biological techniques. We opted for the bio techniques because Mother Nature does it. The CO2, which is trapped somehow in seawater, it reacts with the how can I say, with the elements within the seawater, that is magnesium, calcium, sodium, name it, to form a seashell and to form coral. So we try to copy that process and to make this powder, as you can see. And this is indeed, colleagues, this is these fellows who managed to do it. The commander-in-chief in this is this gentleman here. But that does not stop that the others have contributed extensively. And colleagues, here it is nanoscaled, and it can be used, colleagues, for as you can see, we have confirmed physical, chemical, name it. All techniques have been investigated to show that it's pure calcite. It's exactly that high degree quality of shell that is made somehow. And as you can see, all confirms that. And this is a whitish. It's so whitish that it can be used as a white pigment. It is so good that it can be used as a nanofertilizer, and it's so sound and porous that it can be used as a cement industry. And it's so green and high quality, non-biotoxic, made by green process, that it can be used in a pharma. All the tablets that we take, the tablet, in generally speaking, it's a calcium carbonate, or containing the chemicals, the active phytocompounds that or drugs that we take. And colleagues, while going for R&D translation and giving a chance to the youngsters to have the entrepreneurship vision and the mind shift, that has not stopped us, more or less, colleagues, to embark in publishing in Nature for many journals, as you can see, just showing that there is some excellence in Africa, not at the top level as it's done in the north, but at our level. We are not at the 0 degree Kelvin. We are at the 0 degree Celsius. It's okay, but not the 0 degree Kelvin anymore. And that's thanks to our colleagues from the north and the south, and the members of the diaspora, to whom, wherever they are, in Europe, in Canada, in the US, in Brazil, in China, name it, we are extremely thankful to them indeed. And as you can see, the role of women here, or the impact of women, has just made it clearly, colleagues. Again, colleagues, it brings us to the citations. We are not telling we are at the excellence level, but here it just reflects what we produce is of good quality, and it is impactful worldwide. And our colleagues from the north and the global south, they are citing it. We are extremely grateful to them, showing us more or less as a token of recognition that what we are doing is of quality, and we should continue and pursue in that regard, colleagues. And again, the fellows, colleagues, where they are the ones that we are training within the UNESCO chair, and through these examples, we are trying to convince them that they move now. It's not only knowledge production, publication, citation, what. No, they must also have in their mind, if possible, to embark in a joint stuff with the industry. And as you can see, colleagues, we try to convince them within the technology readiness levels to move from TRL1 to TRL4, laboratory prototyping and testing, and at least to take them at this level and to publish, to go this route. It's extremely difficult, extremely competitive, and does require other skills than the science and technology. And we think that our fellows should be given all the skills to reach that. So we give them a possibility to have entrepreneurship trainings and so on, and also to patent, at least to patent, to show that there is a window of opportunity here. And this is one of the patents. This is with the Turia Khamlish, a PhD student with me, how can I say, at its US patent on the nanofluids by gamma radiolysis. We were the first ones, and so on. And also, colleagues, I plead to you, if you have a high quality publication, do not forget us. Do not forget Nano Horizon, which has been now, which is operational, supported by the Royal Society UK and Science Open International Germany and UNISA Publishing House. It has now an ISBN number that is recognized by the CAMES or by any other institution. Soon this year, at the end of this year, God willing, we will be having a Scopus. It will be on Scopus indexed and the Web of Science indexed and Google and so on. Please, please, please do not forget us, and please send us your publications. I am the editor-in-chief, and I'm supported by outstanding men and women, in particular number 2 in the production chain, Dr. Kaviera Su, with whom we are working. We do work to ensure that we will come to you with the positive response. So I count on you in that regard, colleagues. And again, I wish really to take my role model. I have a number of role models, a really number of role models. In addition to my dad, his soul stays in peace. I have a number of fathers, and directly Chaim Weizmann, the first president of Israel, Madiba, Mahatma Gandhi, and others. But anyway, colleagues, all seems impossible until it's done. And I thank you, colleagues. Shukran jazilan.
Go ahead, Prof.
Yes,
Finish it.
I'm done, dear chair. Thank you so much.
Thank you so much, Prof. I think this is really worth it. And colleagues, I know that we are 14 minutes ahead of time, but I requested for 20 to 25 minutes so that at least we can engage Professor Malik Maaza. I told you he's one of African finest, and you've seen the presentation, how laboratory-based work has actually been translated into actual work where you can see that there is a future for the things that we do, and the fact that we are not only publishing, but we are also making sure that we're solving the socioeconomic challenges we face in Africa. Having said that, we want to prepare for our questions, but before that, I want to call on Professor Bala Diom Ngom, who is the current president of the African Materials Research Society and one of my bosses, to make a very brief remark so that we can continue with the questions. Go for it, Prof. Ngom. I think you're muted. Prof. Ngom, you are muted, so we can't hear you. Can you hear me?
Thank you very much, Desmond, Mr. Chairman. Thank you very much. And sorry for getting in a little bit late. I was in a meeting. I just done. I just wanted to get in just for two things. The first one is just to thank Professor Malik Mazza, whom I know very well. I have been on a journey with him the last 20 years. As an MEC, PhD, and now we become colleague. We are a lot of students that we are co-supervising, and the real sign, he's a really good person that is always engaging excellencies in through the continent. So it is showing that it is possible. So today, once again, he has shown us through the slide that you have presenting that science is possible. We can do top science in Africa, and depend on exactly on how are we engage it, and also according to the people that are surrounding us. So the other second question is that it's an type of information that I wanted to take this audience to give to people before they leave. As the president of the African Materials Research Society, we are engaged in a very serious partnership with the Materials Research Society of the US. So we are heading into the spring meeting where we have our colleague from Africa that are just Professor Mantesai Jale from the University of Pretoria is calling on African participation into this event. And another thing is that himself, Professor Mazza, we have a workshop between the African Materials Research Society and the Materials Research Society of the US. During that spring meeting, we'll be having a workshop, and Mazza is one of those speakers who will be giving a talk on that symposium. So we urge Africans to really get into that involvement, and this will open a way for collaboration. As we know, the science of today is built through cooperation, partnership, through collaboration. So we call on really on this. So because of sake of time, I thank all the attendees for really taking this time to attend this talk, and let us keep tune it and keep in touch with the African Materials Research Society for other great scientists in the continent for their webinar. So thank you, Mr. Chairman. I won't go longer because of sake of time, and thank you very much for organizing this. And I thank also Adele, whom I did not yet met, for the excellent work that she's doing. Thank you very much.
Thank you so much, Prof. Ngom. Prof. Malik Maaza, there is a question for you. Say thank you for your insight And I think I also, after I read these questions, I would welcome room for 2 or 3 questions. One of the things that perhaps I would want to do is there is I think the Secretariat, they've put the emails in the chat. So what you will do is that some questions that have not been answered here, you can actually get the questions to us, and then we'll make sure we reach out to Professor Malik Maaza, and then we can get the answers to those questions for you. So Prof. Maaza, the question is, in which way can we use zinc oxide as a thermocoolant? Nanofluid properties of zinc oxide. So I think that you can take that, and if you want to ask a question, you can just indicate by showing your hand. So Prof. Maaza, go for it as we wait for some questions.
Thank you so much. In effect, zinc oxide, zinc and zinc oxide, they have a very good thermoconductivity also. They can be indeed used to make nanofluids. And the advantage of the zinc oxide, its polarity, its surface polarity. And therefore, because it's polar, either in the zinc oxide, either you end by positive or a negative coordinated surface. And therefore, it will be stable. It will definitely be stable in suspension, and it will not agglomerate. So zinc oxide is also an outstanding component for nanofluids. Yes.
I think Saeed, you wanna see your hand up? You wanna go for more? Saeed, go for it. Saeed, you can unmute yourself.
Yes, I'm doing unmute that one. Thank you very much, Professor Mazza. Just that's very interesting. It was insightful. I like it very much. I was working on zinc oxide for last 5 years around that. So I'm now using zinc oxide, just working on it about its applications in the area of solar cells. But now we're trying to establish nanomaterials or nanofluids to be used in nanocoolants or just nanofluids. So can you use a soldier method or some mechanisms to prepare nanomaterial for this area? Maybe. Thank you very much.
Thank you. Thanks a lot. In effect, for the nanofluids, you have different techniques. You have 2 major families, one single step, and the other ones are a double step. So how can I say? I think the best way for such is just send me an email. And I will guide you accordingly. And what I will do is that I will be making the PDF. I will be sending the PDF copy of this presentation to the chair and the colleagues from the AMRS, and it will be available. Contact them, and they will send you whatever you wish to have.
Thank you so much, Prof. I see Joey Chifamba. Joey Chifamba, go for it.
Thank you. Can you hear me?
Loud and clear.
Okay, fine. Yeah, I am Joey. I am a visiting professor with the University of California in Los Angeles. I am originally from the University of Zimbabwe. So thank you very much, Professor, for the very exciting and interesting presentation. And I found the nanocosmeceuticals, the photoprotection bit quite interesting. I think those who were in Senegal would remember that I presented on similar work that we were doing at the University of Zimbabwe. We were also working on photoprotection using indigenous knowledge systems plants from Zimbabwe, and we managed to commercialize it. I think we got an award a year back for the work that we did. And we managed to commercialize the nanocosmeceuticals, which are based on local indigenous herbs. And I think about 5,000 Zimbabweans with albinism are already using that, because we try to tailor make that to people that are living with albinism. And we are hoping to really roll it out. So what I was requesting for Professor is, I think instead of us working in silos, maybe since we are doing similar work, I think AMRS is aware. I think through Dr. Chigome, they are aware of the work that we are doing. And maybe if we can maybe share notes on the work that we are doing. We are already commercialized in that, and we have had so many hurdles and so many challenges. In fact, trying to take that work to the rest of the world has been such a huge problem. But there's a huge opportunity for that, because I think the 2020 monograph by the FDA actually declares that almost all sunscreens that are available on the market are generally recognizable as not safe. So there's an opportunity to develop indigenous nanocosmeceuticals, which can actually find a niche in the whole world. But I was just requesting that maybe through AMRS, maybe we can be linked with the researchers that they're doing, so that at least they can also get to see what we've been doing. And I think our work is also available. I think if you Google through my name, you can see the work that we've done also on the internet. So thank you very much, Prof, for the wonderful presentation. And thank you to the South African group that are working on such things. And I'm so happy to have been part of this presentation, to hear such wonderful work being done. Thank you so much.
Thank you so much, Joey. And I think, Prof, you would want to comment on that before we bring Zikona. Hello, Prof, can you hear me? But whilst Prof tries to come, okay, Prof, we can hear you now. Yeah. Go for it.
Yes, thank you. Thanks a lot. Indeed, thank you, colleague from Zimbabwe. Indeed, well, the chair is open, no problem. It's an open platform, and we will definitely gain from your expertise. You went through the hurdles and so on. We will definitely work with you. Let's keep in touch, and let's send me an email, and let's take it from there. We will gain from definitely your expertise and the challenges that you have faced and so on. And the most important is that is really to give credentials to our indigenous knowledge, which we should remember that, colleagues, that 90% of the pharmaceuticals existing in the market currently, their origin is a natural compound. And well, that natural compound was indeed being able to to synthetically synthesize it through synthetic biology and convert it to mass production. But nonetheless, the original active phytocompounds, its nature, its origin is a natural compound. And I think up to now, it's mainly the forest of the Amazon, which is the source of that. And in China and Asia, it's mainly some of their dense forest in Thailand, Birmania, and so on. But Africa, the central of Africa, Mauritius and Madagascar are extremely rich in terms of natural extracts. And it's an opportunity for us in general. Thank you.
Thank you so much. Can I also use this opportunity to remind everyone here that one of the things that we hope to achieve with this colloquia is also to build on the collaboration so that we can co-create and cross-pollinate ideas. So this is a good platform. You also look into the chat and use the opportunity to subscribe to our LinkedIn and YouTube platforms so that you can be updated with a lot of things. Now, Prof, before Zikona comes, I want to take these questions and then Zikona will ask, and then you can combine them so that we can finish right on half of the hour. So John Aja wants to know, can we use the nanofluid for targeting drug delivery for cancer treatment? That is the question, so hold on that. And Zikona, can you please ask your question so that Prof can answer, and then we can bring this meeting to an end. Zikona, go for it.
Okay, thank you so much, Chair, and good evening to everybody. So my name is Zikona Chwabingeva, and I'm from the Nelson Mandela University in South Africa. I work on nanomaterials, but we're extracting our nanomaterials from our pineapple leaf fibers, because where we live, we've got a pineapple farm that is literally 80 kilometers away from our university. So the sustainability issue is already covered. And we are using the nanoparticles for different applications. We're using it for electron extraction layer for solar cells. We use it for water filtration. We use it for so many other things. But mine has always been trying to sort of like get an insight into how do we get to commercialize, how do we get to speak to the industry to sort of like help us in order for us to be able to take these particular projects to another level of commercialization and application, because I feel like we are trying so hard, but we are so stuck in terms of we don't really know the correct channels. And I love the fact that our Zimbabwean colleague that just spoke about commercialization and what they actually do with their own material. So mine has always been, I get stuck when it comes to the commercialization, because you do know how the industry people work. And not only that, I mean, when you are an emerging academic, you don't even have the resources that are enough for you to sort of like take your particular research to the next level. So Prof. Mazza, maybe just as a way of encouraging us emerging researchers, how do we go about elevating our research to the next level of commercialization and being out there? Thank you so much.
Prof. Mazza, before you answer the question, can I request that I put your email in the chat for everyone, because some are requesting for it? Do I have your permission to do so?
Please do so.
Thank you so much. Now you can go and answer the question. And once Prof. Mazza finishes this one, we can bring this to a close so that at least we can schedule the next one. Thank you so much, Prof. Go for it. And I'll put Prof. Mazza's email in the chat for everyone.
Thank you, Chair, colleagues. Allow me just to express my deepest gratitude to a role model here, who is here. It's Professor Mohammed Shakir from AMRS, from Canada, who really helped us so much. I think there is a mistake in my email. It's Maaza M, and here it's written Mam UNISA. Anyway, how can I say? I will send my yes, that's it. Yes, thank you. Well, responding to the first question, which is related to, is it possible to use the nanofluids for as a drug? Yes, indeed. How can I say? While the major focus of nanofluids is geared towards heat management, here, for example, the other one is the bio applications. It's really the one who would make a difference somehow, because you can make these nanoparticles, these nanofluids in any fluid, being it blood, being it serum, being it whatever fluid you have, you can do it. And in particular in serum, you can make radioisotope nanoparticles, or you can label radioisotope, label some nanoparticles in suspension, and you can inject them locally, for example, for skin cancer, melanoma, or skin cancer problems. You can inject it locally and treat locally. Yes, the second major application of nanofluid is the bio. Indeed, that's. I hope that I responded to my colleague who asked this question. The second one is that when it comes to the public-private partnership, first of all, it is necessary to show, to demonstrate a pilot unit. How can I say? And that is why we don't go from TRL 1 to TRL 7. We prefer to go from TRL 1 to TRL 4, whereby we validate the process at the laboratory scale. Then, if you want to embark with the industry, you have to move from TRL 4 to TRL 7. And for such, you need to build a pilot unit whereby you show that you can produce your nanoparticles, for example, using a pineapple, you have to show that you can produce a kilogram or 10 kilograms. And here it is another game. It's an engineering approach. And for such, you have to, how can I say, partner with TIA, for example, in South Africa, or other potential SME who believes in your process, but you are obliged to produce kilograms of your nanoparticles. And here it's another game again. I repeat myself. It is not science, it's engineering and it's technicalities. So it is important to have to start at least patent a TRL4 and sell the license, or find a way to have a TIA interested partner who will embark with you to create how can I say, to create a pilot unit. Thank you.
Thank you so much. Joey, Prof. Joey Chifamba, I see. Do you want a quick one before I close?
Yes, sorry for that.
Please
I know
be
you wanted
brief.
to. Yeah. Maybe I just wanted to just go to. I think there was a question to Prof, which I think he answered very well from my South African colleague about commercialization. And maybe was what I wanted to just highlight, I think, from our own experiences, is that, you know, when we embark on these researches in nanotechnology, it must already be translational science. Because I think the problem that we make is, if it becomes too laboratory science and not translational science, it becomes very difficult to take it to a commercial level. So when I talk about translational science, I'm saying is that when you are already, suppose you are working on indigenous knowledge systems, when you're doing the research, you must already consider how the indigenous people have been using this product and how you intend the finished product to be used, so that when you sell the idea, you have a complete story. The problem with getting in partners at a very early age, when it's still just science, is you are at a very low bargaining level. And usually the partnerships are very skewed. So it's always important to make sure that you've got a translational science element to your research, and so that you've got something that is sellable. Most of the time you find researchers have got, more or less half-done researches that they want to sell to commercial entities. So when they get into partnerships, they are at a very low bargaining level, and they rarely benefit much from it. So I would suggest that maybe they bring in elements of translational science to it, or maybe they get somebody who is a translational scientist to make sure that those elements are within the research itself before they talk about commercializing it. Thank you very much for giving me that opportunity.
Thank you so much. And then I'm so grateful that finally we've come to a close, but also perhaps this is to my colleagues and the Secretariat, perhaps this 1 hour colloquium may not be enough time to do justice. So perhaps we should be looking into 1.5 hours. Having said that, I want to thank you all. And first of all, I want to thank the Professor Malik Mazza for your continuous support. Since the Africa AMRS was established, your presence as a board member and also training the next generation of African scientists and engineers, it's really, really, we've seen the progress you've made, we've seen the fruits. Like they said, a tree should be known by the fruit it bears, not the one it talks about. So we are very, very grateful for your time. And I also want to use this opportunity to thank all the people in the Secretariat, from the past president, Professor Dr. Samuel Chigome, to the current president, to the Secretariat, those people that are the background. I'm talking about Lebohang, I'm talking about Adelaide, I'm talking about the rest of the team, for facilitating this process. We're very grateful for your time and all that. We really appreciate what you're doing. And I also want to thank my own big brother, Professor Akin Ojo, who have been doing a lot of traveling the past few days, but he also managed to join us. And also to thank you all the people that I attended. I'm looking at the numbers. We started with 90 something and 58 of you are still here. It shows the commitment you have for the development and also making sure that the science we are doing in Africa is getting to where it needs to. And I also want to also use this opportunity to remind all of us to go to africamrs.net. That is where it is. I mean, the registration for the 12th conference on materials development, it's still ongoing. So take advantage of the early bird registration and start preparing your things, because we will definitely be meeting in Kigali from the 16th to the 19th of December 2024. We would have a pre-workshop, and then we will hit into the conference. We are looking to bring some of the leading minds in the field of material science and engineering across the globe so that we can interact, collaborate, and also develop the next brain. Now, I just want to leave you with some few thoughts. The first one says that it's an African proverb that says, if you want to go fast, go alone. If you want to go far, go with people. This platform is meant for collaboration. It's meant for us to communicate. It's meant for us to engage and discuss issues that confront Africa, and not just talk about it. It is not just going to be a talk shop. It's also, in our small way, finding ways by which we can be able to address the socioeconomic challenges we face, and how we, as the technocrats of this continent, will drive this, partnering with the global north and other to make this thing happen. So I just want to thank you all once again for coming, and I'm really grateful. I'm looking forward when we have our next colloquia, which will be happening sometime next month. And please do subscribe. Yes, Muhammad, I've seen your questions regarding certificate of attendance. I will take this info to the secretariat and we'll see how we can deal with it. So we might get back to you. As far as the president is here, he has also seen it. The secretariat is here, they've all seen it. From our side, I just want to say good morning, good afternoon, and good evening, wherever you're watching us from. And I'm really grateful you participated in this, and I'm looking forward to seeing you at the next one. And so please enjoy your very day, whether morning, afternoon, evening. And when all the things that you do, make sure the thing that I took away from what Professor Malik Maaza said is we are using these things to address the sustainable development goals. And from Professor Joey Chifamba, who talks about translational research. So we are moving from the laboratory to the world, and let's make this thing happen. Thank you so much. And once again, we are grateful for having you, for spending your afternoon, your morning, your evening with us. And bye for now. We will see you next month when we come with the next colloquia. Thank you so much, and bye for now.